So in chapter 13, we're going to talk about our solar system. Our outline is going to be celestial bodies, planet order. We'll talk about the inner planets, all except for Earth. So we'll talk about Mercury, Venus, the Moon, Mars. Then we'll talk about the outer planets, which Jupiter, Saturn, Uranus, and Neptune, comets, asteroids, and then meteors and more. So our solar system is comprised of the Sun. It's the center of our solar system. 8 planets, 4 which are inner and 4 which are outer. We have approximately 150 moons. One of them exists around Earth. There are thousands of asteroids, millions of icy bodies, comets, and much, much more smaller objects. Now, our planets are going to be classified in 3 ways. One is based on their size. The inner planets are smaller, the outer planets are larger. The density, the inner planets are more dense, the outer planets are less dense, and the atmosphere, based on whether or not their atmosphere has certain gases present. Now, the inner planets tend to be rocky, so we call them terrestrial planets because they're more like rocks on the surface. So Mercury, Venus, Earth, and Mars have this terrestrial nature in common. They're made up of mostly rocky materials, specifically metallic and nickel iron core. Now the giant planets, the outer planets, they're called giant planets because they're bigger. They're also called the gas giants because the surface is mainly made up of hydrogen, helium, and methane, and that's going to be Jupiter, Saturn, Uranus, and Neptune. Now there are approximately 15 dwarf planets. We don't necessarily know all of the dwarf planets simply because they are small, they're hard to find. Well, they're smaller, they're harder to find, and they don't always obey by the same path that we're looking for them. So sometimes we find them serendipitously. Pluto is probably the most popular dwarf planet. It's used to be a planet and was downgraded into a dwarf planet because it orbits the sun. It is nearly spherical, but it cannot clear matter from its orbital zone, and it is not a satellite, which are requirements to be a planet. Now, more recently, there is a 10th quote-unquote planet out there, and they've named it Planet X because Pluto at one point was a planet, and so there is theories that there is a 10th planet out there, and that they'll be, based on calculations, that they should be able to see it. But the thing is, the farther the planets get away from Earth, the harder they are for us to see them with the reflected sunlight, and the harder it is for us to capture them because they are so far away. So here is a picture of Pluto. Like I said, it used to be considered a planet, the 9th planet from the sun. There is still some disagreement about whether or not it does qualify to be a planet because it does orbit the sun in the same way that all of our other planets do, whereas some of the dwarf planets don't necessarily follow the same path that you would expect them to take along the elliptical nature around the sun. So you need to know the order of the planets. We have the Sun, Mercury, Venus, Earth, Mars. You can see this is the moon next to the Earth. Then we're going to have the asteroid belt, Jupiter, Saturn, Uranus, Neptune, and then there's the Kuiper belt on the outside, and then little bitty Pluto out there. So we're going to talk about the 4 inner planets. So Mercury is the innermost planet. It harbors shaded water ice at its polar caps, and it's not yellow, it's just, it's colored here so that you can see where the water would be. Its orbital period, meaning the amount of time it takes to get around the sun, is 3 months. However, our 24 hours, which is our rotational period, it takes Mercury approximately 59 Earth days to make one full rotation, which means one Earth day to us is really 59 days on Mercury. Mercury is highly cratered. Part of the reason why is because it doesn't have an atmosphere, and the atmosphere would protect Mercury from incoming celestial objects, and so because it doesn't have that atmosphere, you can see several crater marks on here. They look tiny, but these are probably quite large crater marks if you were on the surface of Mercury. Because it is so close to the sun, when it points towards the sun, it's very, very hot, but then when it's pointing away from the sun, it's very, very cold because of the lack of atmosphere. There's not an atmosphere to keep Mercury's surface warm when it's pointing away from the sun. And Mercury does not have a moon. This is not a real image of Mercury colored, but it is what it is distinguished based on high and low points. And you'll see, so the blue are low points, the yellow is high points. So there's a little bit of what we would call topography on Mercury. Some of it's probably because it has been cratered over time by objects because of its lack of atmosphere. Venus is what we call the morning and the evening star. It follows pretty close to the sun, so sometimes you'll see it come up, or you'll see it just as the sun is going down. It'll be trailing behind the sun. And it's normally what we would call the second brightest object in our sky, and so I hope you can think about what the first object would be in our sky, and it's not the moon. But Venus is the second brightest object in our sky. It does exhibit phases like the moon, so full moon, new moon, the waxing crescent, and all of that. One thing that makes Venus unique is its rotational motion is opposite of its orbital motion. So if it's going around the sun in a clockwise position, it's actually spinning on its axis in a counterclockwise position. So everything else will spin in the same direction that it's orbiting, but Venus will spin opposite of the way it's orbiting. Another thing that makes Venus unique is that the day of Venus is longer than the entire year, which means that Venus can orbit the sun faster than it makes one complete turnaround on its axis, which is strange, but it's rotating so slow that it's able to orbit around the sun faster. But it is closer to the sun too, so we would expect that a quote-unquote year on Venus would be shorter than Earth. Now, Venus has been visited by a number of probes, and so we know some interesting things about Venus for that reason. Now, if we were to look at Venus, it's going to look like this. It's mostly a carbon dioxide atmosphere, and so that's what this fuzzy stuff is that we see here. There are swirling clouds of CO2. It's very, very hot on Venus, partially because of how close it is to the sun, but also the CO2 atmosphere. It's a warming gas, and so it's going to make Venus quite warm, and there's going to be an intense amount of pressure because of all of the carbon dioxide gas pushing down on the surface. So on Earth we can stand up, but on Venus you would not be able to get up off the ground. The pressure would be too intense. Now, if we could remove all of the clouds around Venus, what we would see is this image right here. And so we know that the surface is mostly flat, but there is some variation. We can see the dark spots and the light spots, which show different elevations along Venus. But it does have an atmosphere to help protect it from being heavily cratered like we saw with Mercury. There we go. So Earth's moon, we're not going to talk about Earth in this chapter because we're going to spend all of chapter 14 talking about the Earth. But the moon is really important to us. It's the closest object to us, and it plays an important role that we'll see when we talk about tides and other things, seasons. So on Earth's moon, we have what's called the lunar highlands. These are these light-colored mountainous regions. We have breccias, which are rock fragments compacted from meteorite impact. There are mareas, which are the smooth, dark areas formed from lava flow. And then what these are made of is called basalt, which is similar to rock that's formed from cooling lava on Earth. Basalt is actually, we're going to see, is going to be one of the main minerals, rocks that makes up our oceanic crust. So we know a lot about basalt because we can study it here on Earth, and we know that the mareas on the moon are made up of very similar type rock. The moon is heavily cratered due to bombardment of meteorites. In fact, its surface has been bombarded so much that the first 3 meters, if you took a meter stick and shoved it down into the ground, it's actually just gray dust that contains microscopic glass beads. So the funny thing about the moon is because of the bombardment, at one point they thought the moon experienced what was called moonquakes, maybe thinking that the moon had geologic activity similar to Earth, but in fact it was because of the meteorite impacts that we detected moonquakes on the moon. Now, Mars is sometimes called the sister planet to Earth. It's the most similar in size and some other things. It's also called the red planet. There are geologically active regions with inactive volcanoes, canyons, terrace plateaus near the poles, flat regions pitted with craters. So all in all, it's geographically very similar to Earth. Having a volcano suggests some sort of undersurface activity, geologic activity. Canyons, like the Grand Canyon, suggest water flowing specifically. And in fact, Mars has a Grand Canyon that is much larger, or has a canyon that's bigger than our Grand Canyon, which suggests that there's strong evidence for liquid water that flowed. The atmosphere there is very thin. It's not thick like ours, and it's also made out of mostly CO2, which is not habitable for life. And Mars, unlike some of the other planets, has been visited by numerous space probes in the past. And of course, one of the things Mars is most known for is the idea that there might be life on the planet, but we know that there is no life like what we see on our planet. And so there are no aliens living on Mars. Though it's infamous that aliens living on Mars is kind of a thing I remember learning. Is there life on Mars or not? So now we're going to talk about the outer planets. The outer planets are gas giants, Jupiter, Saturn, Uranus, and Neptune. So Jupiter is the most massive planet. You probably have learned that at some point. It's 318 times Earth's mass. So that's pretty heavy considering that Jupiter is made out of gas. A large portion of it's made out of gas. It tells you how large Jupiter would be with respect to Earth. So Jupiter is mainly made up of hydrogen and helium gas, and it does have an iron silicate core. We're going to talk about silicates when we get to Earth science and start talking about geology. Its atmosphere is what we would call dynamic, so lots of weather, what we would think of as weather. So hydrogen, helium, ammonia, methane, water, none of those things are things you want to be breathing in, even the water. So it's not going to be habitable for life. But what it leads for is really pretty pictures. So all of these oranges are these methane, some sulfur, and those swirling clouds that we see is weather. Now the great red spot is what Jupiter is probably really infamous for, and that's this storm. It's a big storm, a big cyclone system that's existed on Jupiter for over 200 years. And occasionally in images we've seen a smaller storm pop up next to the big red spot, but we know now that it's just an area of very intense weather. Now Jupiter has nearly 70 widely varying moons. These are examples of some of Jupiter's moons: Io, Calypso, Ganymede. They were named after some Greek mythology type roots. But we know that Jupiter is surrounded by lots of moons. They vary in their shape, their size, their composition. So Saturn is our next planet. Saturn is most infamous for its rings. In 2004, the International mission entered orbit around Saturn and was able to get some really good images of Saturn. We know that the rings are ice-covered particles that are just traveling around in orbit of Saturn. But Saturn is also surrounded by around at least 60 moons, one of them being Titan, which is the only moon with a substantial atmosphere, meaning if life was going to exist somewhere, it's going to exist on Titan, because it's the one that has the closest conditions for the things that life would need to exist. Now, one of the things that makes Saturn unique is its density is much less than water, meaning if you could find a pool that was big enough to put Saturn in, it would float. Another thing that's really unique about Saturn is when it rains, the pressure is so intense on Saturn that it rains diamonds. Your good old-fashioned, put a ring on it, diamond. Uranus and Neptune are our last two planets. We kind of cover them together because they're so very similar. They're the outermost icy giant planets. They're very similar in size and their internal structures, which is a rocky core with water and ice. One of the things that makes Uranus unique is that it does have rings like Saturn, but they are up and down, vertical instead of horizontal. And other than that, they're both represented here in blue as icy and cold. If you were to try to communicate with someone on Uranus, it would take 2.5 hours for them to hear your transmission, one word. To do that same with Neptune would take 8 hours. So it would take a long time to have a conversation with anybody on those planets. So we're going to take a break here. You're going to pick up with chapter 13 in the next day, and then have an assignment over chapter 13 material.